Okay, this video will explain part of Learning Outcome 4.4. So the grain structures and solidification of growth of dendrites, and 4.7 demonstrate an understanding of the relationship between the solidification process and the cooling curve. Alright, so the first bit, if you think of material or metal being mined, alright, it's then put through a heat treatment process and gets rid of all the impurities. Right, so it becomes an ore. Now if you think back to when we were discussing the heat temperature graph, we were talking about mild steel in this case. We have a lower critical point, which is 720 degrees, and then you have an upper critical limit, which is 1150 degrees approximately. So in between that's when your material starts to become liquid. Under 720 it starts to solidify. Now as the metal is molten and it starts to solidify, the atoms start to group together, and that's what these red dots denote. The cooler the material gets, the more the atoms group together, and they form, in this case, like little Christmas trees. They're called dendrites. Now dendrites comes from the Greek word dendros, which basically means trees. These dendrites are expanding, and as they expand, more and more atoms are joining them. So they change shape and they become like Christmas trees, and they'll go to a point where they cannot expand anymore. Alright, they've completely expanded. Now they don't merge together, they just basically stop. And when they stop, as you can see that they're getting larger, they form grains and become a grain boundary. So they go from a liquid state to a solid state, alright, and a dentritic state. When you're watching the video, you'll see that happen in real time as they do the experiment. Now, regarding the heat curve, regarding the cooling curve, we have our graph. We'll just do this for carbon steel. We have time, and then on this side, which has just been cut off, is the temperature. So I'll move that across to there so you can see. So what we have is our temperature curve. There's 720. Starting at 1150, we've got A, B, C and D. So for A, between A and B, the molten steel is liquid. And you can see the little grey dot at the top is to show you the dendritic images before. So between A and B, it's in liquid form. Then between B and C, we have the formation of the nuclei. So this is what is actually happening. When you get to point C, we then start having the growth of dendrites. And then finally we have the grains of solid material as the temperature goes under 720 and it continues to get colder. Now this is all well and good. There are methods in manufacturing where they use supercooling, and it's between this point B and C. What they do is for a moment or two they just cool everything so that the growth of the nuclei is greater. So we go from there. So the formation of the nuclei, right, more nuclei are formed, and therefore you have a better grain structure. Right, so For 4.4, 4.7, demonstrate and understanding the relationship between the solidification process and the cooling curve. So we have the cooling process, and then that is how it's linked to the curve. All right. So hopefully from that you can answer any of the questions.